Hello friends, good evening. Good evening friends. Is it clear? Audio video, is it clear? I think slides are not changing. Slides are changing or not? Okay, in the previous session, I have discussed cyclomatic complexity. We saw what is cyclomatic complexity, what is the use of cyclomatic complexity, and how to find the cyclomatic complexity. And we saw the UGC net previous year question also, right? From the cyclomatic complexity, we saw UGC net 2019 question also. Okay, friends, now I will explain about software design. It is also very important. Every time question is coming from this area. Okay, main motive of the software design is that uh, prepare in that way which is effective for future extension or any change if required. What is a design? How to design a software? That means if any future if we want any changes or if we want to any extension in the software, it should be very uh, easy to change, right? That is called as, that is our motive behind the software design. We can change a part without affecting the total software. Software means there are different modules are there in that software, right? How to uh, if anything is changing in the software without affecting the other module or other complete software, right? We can change a part without affecting the total software. For this we are using the concept of modularization. Okay, yes, we can change a part without affecting the total software. For to achieve that, we are using the concept of modularization. Okay, that is, modularization means technique to divide a software into modules. Instead of doing software blindly, we are uh, dividing the total software into some modules. Okay, first one is, two important terminology here in the module concept is cohesion and coupling. The measure of the, what is cohesion? The measure of the, I will share, wait. Okay, friends. Yes. What is cohesion? I will wait 1 minute. Some maybe some other people will join. Software design means how we are designing our software. That is our software design, friends. Okay. What is how why we have to concentrate on software design? If in future, if we want any extension or any change in the software, that should be changed in very easy way, right? We can change a part of the software without affecting the total software. For this, what concept we came modularization. What is modularization? Technique to divide a software into modules. We are dividing the total software into some modules. Okay. In the concept of modularization, we got to here two concepts we have to know. One is cohesion and another one is coupling. These cohesion and coupling terminologies are very important for UGC net. Maximum most of the time question is coming from the cohesion and coupling. Okay, what is cohesion? What is coupling? The definitions they will ask. Okay, cohesion means the measure of the strength of functional relatedness of functional relatedness of elements within a module. Okay, degree of dependability within elements of module. Suppose we are developing the software in module wise, right? Suppose this is a module 1 and this is a module 2. What is the cohesion means? The intradependency. Suppose these are the different elements within a module. The dependency, within a module, the these elements are depending on one another, right? This is called cohesion. The dependency between the elements of within a module. This is called as a cohesion. Again, in the software, we may have more than one module, right? What is coupling? Coupling means the degree of interdependence between two modules. The dependence between two modules. Here, this is module 1 and this is module 2. The dependency between two modules interface and interact with each other. This is called as coupling. The interdependence between two modules is called as coupling, and the intradependency within a module is called as a cohesion. Okay. See, I explained here with examples. This is module 1 and this is module 2. Here there are two elements in the module 1. The dependence intradependency between these two elements within a module is called as cohesion. This is called as cohesion. Please remember this. And the dependency between two modules is called as what? Coupling. This is called as coupling. An important design objective is to maximize the we have to maximize the module cohesion. Within a module, there should be a strong relationship and minimize coupling. Between the modules, there should be less dependency. That is here. We have to minimize the coupling and maximize the module cohesion. Maximal relationship within modules. That is called as cohesion. Maximal relationship within modules is called cohesion, and minimal relationship between modules coupling. Yeah, that is we have to focus on this. This is not definition. In cohesion, we have to focus on maximal relationship between modules. In coupling, we have to focus on minimal relationship between modules. Okay. There are different types of cohesion and different types of coupling also in the based on different types of cohesion and different types of coupling. Every time last time also question came on uh, I think coupling. Question came on coupling. Every maximum it is most important. Okay. What are the different types of cohesion? We will see which is highest and which is best and which is worst also we can see here. Okay, it is an extension of information hiding concept. What instead that means first one is functional cohesion. What is functional cohesion? Both perform one action as a team. This is the highest degree of cohesion. That means without if within a module suppose within this cohesion is we are talking about cohesion. That means it is within module only. Okay, how the elements within a module are dependent. Based on that, we are saying it is good or bad. Okay, so what is functional cohesion? Functional cohesion means both perform one action as a team. Okay, these both are performing one action as a team. That means with without this cooperation of these two elements, that work cannot be done. That's why it is very important, right? These two are doing a function as a team. The elements of the module are grouped. Why these elements are grouped? Because they all contributes to a single well-defined function. It can also be the elements of the modules are grouped. Why these elements are grouped? Because they contributes to a single well-defined function. These two are focusing on a single function and well-defined function. That's why it is this is the highest best cohesion. Okay, which is the best cohesion? Functional cohesion. Why? Because contributes to a single well-defined function. They are uh, by performing one action as a team. Okay, that's why functional cohesion is the best cohesion. That is the first. Next one is sequential cohesion. Output of one element serves as a input to other and so on. Suppose this is the element 1. After A1 completed its action, it is giving output. This output to this output is working as an input to other next element. Okay, this one has to wait. This element B1 is depending on the element A1. That's why these two are grouped. Okay, this is called as sequential cohesion. One after another is doing their job. Okay, next one is communicational cohesion. Elements contributes to activities that use same data, input and output. Communicational cohesion means they are using same data. Okay, this A1 element A1 and element B1 are using one common data. Okay, that is called as communication cohesion. These two are communicating through this global data. That is called as communication cohesion. First one is functional cohesion. This is the best cohesion. Second one is sequential cohesion. Output of one element serves as input to another. Okay, next one is communicational cohesion. Elements contributes to activities that use same data. These elements are using the same data. Next one is procedural cohesion. This is different work but related by sequence. Okay, just these are there is no actually in functional or sequential that nothing is there between these two elements, but they are sequentially related. Okay, after A1 B1 is doing, but output it is not getting output also. They are not working as a team. No, nothing. Just these are just sequential. One after another is doing. Okay, that is a procedural cohesion. these activities of these two elements are unrelated. This is doing another activity and this is doing another activity, but just they are sequentially, they are related, similar to sequential, but elements are not related. Add and edit module, write and read module, these are the examples. Suppose if you are adding anything and we are doing editing after that, these are the different tasks, but these are sequentially one after another we will do. Next one is temporal cohesion. This temporal means in that word only the meaning is there, related to time. Elements are processed at a similar point of time. Okay, these are, these elements are related on the time. A is also doing at the same time is this work, and B is also doing same time. That is called as temporal cohesion. Just you remember that. That is easy. They will ask like which is highest cohesion, highest to lowest, lowest to highest, best, which is the sequence, they will ask like that. Okay, next, logical cohesion. When logically categorized elements are put together into a module. Here also here nothing is related, just logically, just they will think logically and they will put into a module. Okay, there is nothing they are doing, nothing, there is no relation. Next one is coincidental cohesion. Unplanned and random. It is a coincidental. That means unexpectedly they will put into one module. There is no relationship between the other elements. That is called the coincidental cohesion. Okay, please do revision. First one is functional cohesion. This is the best cohesion, right? Because these, the elements in this cohesion are doing a well-defined work and they are doing working as a team. That's why it is the best cohesion is functional cohesion. Next one is sequential cohesion, right? Sequential cohesion. That means one output is working as a input to other element. Next one is what? Next, third one is what? Communicational cohesion, right? Communication means they are using same data. They are using the same data. That's it. They are not related, but they are using same data. This is communicational cohesion. Fourth cohesion is procedural. Just they are related by procedure or sequence. Next one is temporal cohesion. They are related, just they are performing their task on the same time. Next cohesion is logical. By just by thinking logical only, they are related. Next one is what? Seventh one, coincidental. This is the worst cohesion, right? There is nothing is related here. Just by coincidentally they are together. But actually nothing is planned in this cohesion. That's why this is the best is functional and worst cohesion is coincidental. You have to remember, please write one in one place and we have to remember this. Next, we will go for coupling. What is coupling? We aim to minimize coupling. Yes, our aim is to minimize coupling. Coupling means what? The relationship between two modules. We have to minimize the coupling to make modules as independent as possible. In future, if we want to change something in one module, there should be less dependence on other modules. Suppose if we want to change anything in one module, if it is strongly dependent on other module, this module also will affect, right? That's why there should be minimum coupling. Minimum coupling should be there. Okay, low coupling. How can we achieve low coupling? Eliminating unnecessary relationships, right? If there any unnecessary relationship between these two modules, if we can eliminate that, the coupling will be reduced, and reducing the number of necessary relationships. First, we have to reduce unnecessary relationship, and we have to reduce necessary relationships also, is if possible. Next, causing the tightness of necessary relationship. In that necessary also, we have to make some more uh, strict on that necessary also. All time we can't avoid coupling. In all the time we cannot avoid the coupling, right? Sometimes we there is a compulsory need to relate with other module. That time we cannot avoid, but whenever there is a possibility, uh, reduce the necessary relationships. So prioritize the coupling most required to least required in. That means most required first we have to give priority, next least required. Next one is, what are the different types of coupling? There are five types of coupling are there. This came in the UGC net exam. I forgot actually. These are cohesion. Both are very important. Please try to understand, and please do add your note in your notebook also. Okay, five types of coupling. First one is data coupling. Modules are interact with each other by passing data. Here the relation is between modules, right? Coupling means relationship between modules. Modules are interact with each other by passing data. How they are interacting? By passing data. It is passing some data to this, and it is passing this to this. Next one is stamp coupling. Share same data structure and work on different parts of it. They will share same data structure. Okay, like communicational cohesion, right? In communicational cohesion also, they are using the same data. Here also, uh, here these are sharing the data, they are using the same data. Same meaning. Here stamp coupling means share same data structure but work on different part of it. Different module is using different data. First one, best coupling is data coupling. Modules are interacting with each other by passing data. Next one is stamp coupling. They are sharing some data structure and working on different parts of it. Next one is uh, control coupling. Communicate each other with the help of control like flag. Okay, they are communicating with each other by using a control like flag. Okay, that like true or false, like that. They are communicating with each other. Next one is common coupling. Use of global data as communication between modules. Okay, this is common coupling. They are using the common global data here. Okay, global data as communicating between modules. By using this global data only, they are communicating. That is called as common coupling. Next one is content coupling. This is the least coupling. A module can directly access or modify or refer to the content of another module. This is the worst coupling because one module is directly without any condition. This module one is accessing and modifying this data also. It is not good, right? It is not the good practice. Directly modifying the data is not a good one. It is changing the data of another module. That's why this is worst coupling. Don't confuse with the data coupling. Okay, data coupling means don't confuse this content coupling with data coupling. They are looking like same, right? That's why data coupling means modules are interacting with each other by passing data. Whereas content coupling means they are changing, one module is changing, accessing, modifying the data of another module. That's why This is the worst coupling and this is the best coupling. Next, second is stamp coupling. They are using the they are sharing the data structure and work on different part of that data structure. Next one is control coupling. Control coupling is communicating each other with a flag. Okay, next one is common coupling. Common coupling means they are using global data as communicating between the modules. Okay, friends, please try to remember these terms. It is very important terminology. Okay, okay, now we will go for the testing part. The remaining testing part is there now. What is the different types of testing, and next after that we will go for the black box testing. Testing means first verification plus validation. Okay, in the initial stage what we will do, code, we will develop the code, right? Whenever we are writing code, we will do unit testing, right? For every module, for every code we are doing unit testing. Okay, that is called unit testing. After coding, what we will do, we will design the modules. In the modules, what type of testing we will do, integration testing. Yes, in the design phase we will do integration testing, and actually it is going from wait a minute. Yes, initially we write the code and we will do the unit testing. Next one is design phase, and in design phase we will do integration testing. And yes, yes, one important point here is, please try to understand this. While doing testing, this is the we are going outwards of the circle. While developing, testing is conducted by moving outward of the spiral. Okay, like uh, by moving outward of the spiral we are doing testing. The software is developed by moving inwards of the spiral. This is software development, like this. Okay, testing is outward of the spiral first. Okay, friends, now I will explain. Yes, the testing is first, what testing we will do? First, development, how we will do system engineering, right? Next one is requirements. What are the requirements we will gather? And next we will do designing and we will do coding. System engineering means what we will do the, what is the actual system and how everything we will do in the system engineering. Okay, next we will do, we will gather the what are the requirements of that system and we will design that, and we will finally we will do the coding of that design. Okay, this is the software is developed by moving inwards this spiral. That means first system engineering, in the next step we are requirement gathering, in the next step we are doing design, in the final step we are doing coding. Okay, the software testing is conducted outward in testing is conducted by moving outward of the spiral. How? First, after coding, what we will do, first we will do unit testing. After that, unit testing, after all the modules are joined, and we will do integration testing. Then after we will do validation testing. Then finally, we will do the system testing. Okay, this is the all about this diagram, friends. The software is developed by moving inward, means system engineering requirements, design code. And testing is unit testing, integration testing, validation testing, and system testing. Now we will see everything in detail. Testing means, what is testing? That is verification and validation. Verification means, are we building the product rightly? Okay. This also very important terminology. Verification means, just this is, we can see physical, actually, are we building product rightly, meeting business requirement, whatever the customer is saying, in that way only we are developing or not. Does it this verification does not involving executing the code, human based checking of document and file. Just this verification is not there in any execution of code, anything is not there. Verification means, just we will check the documents and our whatever the document we prepared, whatever the uh, file we prepared, now we checking, just we will check, are we meeting the business requirement, that is, are we building the product rightly, it will come last. Please remember, sometime verification validation definition also came in the exam. Are we building the product rightly? Next one is validation. Validation means, are we building the right product? This is, it will come involving the executing of the code. After executing of the code only we came to know, is this right product or not, right? That's why in validation phase, what we came to know, is this right product or not. In the verification phase, just we have to check manually the document, are we building the product rightly, are we going in the right direction, okay, are we meeting business requirements or not. This is called verification. And are we building the right product? This is meeting user requirement and customer expectation. Computer based execution of programs. In the validation phase, how we will check? We will execute the programs. These are the differences between verification and validation. It is to check whether the software conforms to specifications. And validation, it is to check whether software meets the customer expectation and requirements. In verification, just we will see, check whether software whatever the specifications are there, are we conforming. Here, are we meeting the customer expectation and requirements in the validation phase. And second point is, uses methods like inspections, reviews, walkthrough, and desk checking. What are the methods here? Inspections, they will do some reviews, walkthroughs, and desk checking they will do. Whereas in validation, uses methods like black box testing, white box testing. Yeah, it is doing the functionality and internal mechanism of the program. Next one is, are you building the product rightly? This is the keyword, product rightly. Next one is, checking inconsistency between detailed specification user requirement. Here in validation phase, what we can observe, right, what is our detailed specification and user requirement. Is there any inconsistency between these? Okay. Is there any inconsistency between the specification and user requirement? Generally, it will follows after verification only, right? Yes, this is the difference between verification and validation. Please, if you have any doubt, please ask me. Is it clear? If you have any doubt, please tell me. Please Okay, I hope you are clear. uh, Next, testing levels. What are the different testing levels? We will see this unit testing and integration testing, system testing. Okay, what is unit testing? Size of single module can be tested easily, works on coding. Okay, here in unit testing, single module will be tested. Okay, it will work on coding. Wait a minute, friends. Okay, here we will see unit testing. This is about unit testing and integration testing. What is integration testing? All the modules work fine if integrated together. Here what we will do, we will combine all the modules and we will do the testing. In the integration testing, works on designing. There are different types of integration testing. First one is top down integration, bottom of integration. Next one is regression testing, smoke testing. These are the different types of integration testing and system testing. The behavior of the whole system as defined in SRS. Here what we will do, whatever we SRS means we will write before the development, right? Software requirement specification. Is it there according to the SRS or not? It will do recovery testing and security testing, portability testing, performance testing. Okay, how is it recovering and security? Is it providing security or is it giving portability, performance? Everything will be tested in the system testing. We already saw, right? These are testing approaches. Functional testing means black box testing. Next, implementation testing is white box testing. Okay, we will discuss this black box testing also. Okay, yeah. First, we will see what is unit testing. Unit testing means it focuses on smallest unit of software design. In this, we test an individual unit or group of interrelated units. Okay, small units and individual units we will check here. It is often done by programmer by using sample input and observing it corresponding outputs. The programmer only will do this unit testing by using sample inputs and observing that corresponding outputs. Okay, smallest unit of software design. The unit testing is done on smallest unit of software design. Okay, that is in a program we are checking if loop or method or function is working fine. Just if we check only one loop or only one method, one function, that is called as unit testing. Misunderstood or incorrect arithmetic precedence. If there any incorrect is there, and incorrect initialization also may be there, right? In the code, incorrect arithmetic precedence or incorrect initialization of the in the program. Okay, these are all we can find in the unit testing. Next one is integration testing. Integration testing is the objective is to take unit tested components and build a program structure that has been dictated by design. After doing the unit testing, all the unit tested components we have to take and we have to build a program structure that has been dictated by design. Integrated testing is a testing in which group of components are combined to produce outputs. All the components, whatever are there, which are done in the unit testing, in the integration testing, we are combining all and we are doing the integration testing. Integration testing also three types. One is top down testing, bottom up and big bang approach. Okay, we will see what is top down testing, bottom up testing and big bang approach. Top down and bottom up approach are carried out by using dummy modules known as stubs and drivers. Okay, why we need stubs and drivers we will see now. These stubs and drivers are used to stand in for missing components to stimulate data communication between modules. Okay, suppose if some modules are still in the developing stage, how we can do in the integration testing? That's why we are using stubs and drivers. Okay, we will see where the stubs, where the drivers are using. These are stubs and drivers are dummy modules. Like in prototype, where we are doing some dummy okay model, right? Like that in the we are here we are doing stubs and drivers. We are using these terms comes into the picture while doing integration testing. We face the situation that some of the functionalities are still under development. We will be some of the functionalities are still under development. We have to replace with some dummy program. These dummy programs are named as stubs and drivers. These are stubs and these are drivers. Where we will use stubs? Top down approach. Okay, in the top down approach, okay, top level modules are ready, but these are under down level modules are under development. These programs are under development. That's why we are using some dummy modules here in the down modules. Those are called stubs. Okay, whereas in bottom up approach, the down in the login is not ready, but profile is ready here, right? In the downside modules are ready. That's why here in the login, that's why we are calling it as a bottom up. Bottom is ready here. Like this we can remember, right? Bottom up means bottom is ready, top down means top is ready. That means upside, that is driver. Up means it is driving, right? Without it is not possible. This is a driver. Like that we have to remember in the exam. Driver is not ready. That's why we are using driver here. In the place of login, we are using dummy module. That dummy module is called as driver. In the down, uh, down is not ready. They are called stubs. In the bottom up is not ready. The login module, whatever is there in the first, they are not ready. They are called as driver modules. That dummy modules are called as drivers. These are important terminologies, friends. Please remember these also. Next, we will see what is top-down approach. Testing takes place from top to bottom. Okay, this is module 1, this is module 2, module 3. The down modules are not ready. Still some modules are not ready here. That's why we are taking dummy modules here. These are called stubs. The high level modules are tested first and then low level modules, and finally integrating the low level modules to the high level to ensure the system is working intended. Here these are the high level, yes, first level high level modules tested, and then low level modules finally integrating the low level modules to the high level to ensure the system is working in as intended. Stubs are used as temporary module if a module is not ready for integration testing. In top down approach, what we are doing, high level modules are tested first. First we are testing high level modules. Next we are testing low level modules. Okay, to ensuring the system is working as our requirement. Okay, in that process, whichever the modules are not ready, that modules we are taking as a dummy modules. Okay, next we will go for the next one. Yes, bottom up we already discussed, right? Next one is these are all the black box, the different types of black box testings. First one is pairwise testing. All pair testing are pairwise testing. This is a type of black box testing taken for testing the software using combinational method. Okay, it is a method to test all the possible discrete combinations of the parameters involved. This will test all the possible desirable combinations in the pairwise testing. Okay, suppose with sample list box. Suppose there is a list box 0 to 9 are their numbers along with a checkbox, radio button, text box and OK button. The constraint for text box is it can accept values only between 1 and 100. Below are the values that one of the GUI can take. List box we are testing by 0, 1, 2, 3, 4. Like this we will give here in any one we can select. Checkbox means like this. It is checked or unchecked. And the radio button means it is on or off. Text box any value between 1 and 100. This is called as a pairwise testing. We will give all possible discrete combinations of the parameters involved. Okay, we will give the possible combinations of the discrete parameters and we will test like list and checkbox, radio button, text box. Okay, next one is Big Bang approach. This is also a black box testing, combining all the modules once and verifying the functionality after completion of individual module testing. Okay, we will combine all the modules once and we will verify the functionality after completing the individual module testing. Suppose there is a transaction module and report module, we will combine transaction plus report, then we will do the testing. Okay, next one is validation testing. It is coming under the validation testing, right? What is acceptance testing or validation testing? Ensure that the product actually meets the client needs. In validation testing, what we will came to know, are we meeting the client needs? Okay, alpha testing, beta testing. These are also very important terminology. Alpha testing means done before the product is released. Suppose we already completed the software development, but before releasing to the customer, okay, in QA people is there, right? Quality people, quality assistant, they will do the testing of that software within the organization in the controlled environment. No one is there. Okay, in the developer site. This alpha testing is done before release to the customer. It is typically done by QA people performed internally within the organization. This alpha testing where it will be done within the organization. Okay, beta testing is sometimes we will listen, right, this is a beta version, like that. Beta testing means this version released for the limited number of users for testing in real time environment. Okay, they will release for some number of customers in real time environment. Okay, then the customer can test his product at his own site, right? The customer also using that product and he will give that feedback, is it okay or not. This is alpha testing is at developer site and beta testing is at what, This is a what? This will release for the limited number of customers. The uh, customer tests the product at his own site. This is called as alpha testing and beta testing. Next, what is regression testing and smoke testing? Regression testing means every time new module is added to changes program. Suppose software we need, after some time the customer want add some new module to the project. Then this type of testing makes sure that the whole component work properly even after adding components to the complete program. In regression testing, what they will do, if after adding, if a new module is added also, the the complete software is working fine, works properly even after adding components to the complete program. This is called as regression testing. Please remember, most of the time this based on these definitions only question is coming. Okay. Next one is smoke testing. Make sure that software under testing is ready or stable for further testing. Software under testing is ready for other, it is ready for further testing also. This is known as smoke testing or build verification testing. The term came from hardware testing, in which device passed the test if it not catch the fire for smoked. Okay, the first time it was turned on. Okay, suppose there is a gas stove is there here. Device pause test if it is not catch the fire. Okay, if we open the gas and we lighting the gas, if it is not catch the fire to outside, then only it is okay. Okay, first time it was turned on, whenever it first time we are checking, it should be work fine only, right? That is called as smoke testing. Next one is system testing. What is system testing? In this software is tested such that it works fine for different operating system. It is covered under the black box testing only. Is the system portability means it has to be work for the different operating system, right? In this, we just focus on required input and output without focusing on internal working. We will not focus on internal working, right? In the black box testing, just we will focus on the output. Is it working fine or not? This includes functional as well as non-functional testing, security testing, stress testing, performance testing. In the system testing only, we will do security and stress testing performance. What is stress testing? If we give unfavorable condition to the system and check how they perform in this condition. Unfavorable means, suppose example, test cases that requires maximum memory or other resources to execute it. Stress means unfavorable condition. Suppose if the app, suppose if we take some app, education app, so it will be work fine only up to 100 participants. Okay, if we suppose we will give more than 100, then we will see is it working fine or not. Okay, suppose the limit, if we cross the limit, is it working fine or not. Like that, if we give some more stress, that means the more than that capability, if we do, how is it working. Unfavorable condition means that only, right? It is not favorable condition. Now we will see how that system is performing. Next, what is performance testing? Designed to test runtime performance of software within the context of integrated system. How the runtime of the performance of software within the integrated system. How it is performing. It is used to test speed and effectiveness of program. Performance means speed also will comes, right. Effectiveness, we have to, we need speed also, we need effective performance also. Next, what is security testing? Testing techniques to determine if an information system protects data and maintains functionality as intended. Okay, security means it has to protect the data and maintain the functionality. There should not be any uh, data mean means what? There should not be any like data loss or data cheating should not be there in this. The security, it has to protect the data and the functionality also, it has to work fine. It also aims at verifying six basic principles. What are the security principles? We need confidentiality. No other one can see the privacy. That is, confidential information should not be shared with other. Integrity. Integrity means it has to be honesty and moral, like that. Okay, next, authentication. Authentication means it has to check the user, is that user correct user or not, whoever our login is correct one or not, it has to check and allow. Authorization means it is security, the system security, the data security is coming under authorization. Is it available or not, is it uh, this is non-repetition means there should be, it is also comes under security. Okay, there should be some digital signatures, it has to follow. Okay, to give more security purpose. Okay, next one is security testing techniques. There are different security testing techniques also. Injection, broken authentication and session management, cross size serping and sensitive data exposure, unvalidated redirectants, forwards. These are the different security testing techniques. These are next. Next, what is endurance testing? This is very important, also known as soak testing. Types of non-functional testing. This is also type of non-functional testing. This testing involves testing a system with a significant load extended over a significant period of time to discover how the system behaves under sustained use. Suppose, what is endurance testing means? Testing a system with a significant load. We have to give some load and we have to extend that over a period of time. A system may exactly as expected when tested for 1 hour. Suppose if we test it for 1 hour, it is working fine. But when the same tested for 3 hours, problems such as memory leak cause a system to fail as behave randomly. That's why we have to test for 3 hours. Like that, we have to extend over a significant period of time. Okay, load. We have to increase the load, that is called as a endurance testing or soak testing. Okay, friends, please do this revision up to here. Whatever the remaining black box testing, I will cover in the next session. Please do your revision. If you have any doubt, you can ask me. Thank you, friends. Thank you. Bye, friends. Bye.